Understanding Climatic Change, a Program for Action, by the U.S. Committee for the Global Atmospheric Research Program. Climatic change has been a subject of intellectual interest for many years. However, there are now more compelling reasons for its study. The growing awareness that our economic and social stability is profoundly influenced by climate, and that man's activities themselves may be capable of influencing the climate in possibly undesirable ways. The climates of the Earth have always been changing, and they will doubtless continue to do so in the future. How large these future changes will be, and where and how rapidly they will occur, we do not know. A major climatic change would force economic and social adjustments on a worldwide scale, because the global patterns of food production and population that have evolved are implicitly dependent on the climate of the present century. It is not primarily the advance of a major ice sheet over our farms and cities that we must fear, devastating as this would be, for such changes take thousands of years to evolve. Rather, it is persistent changes of the temperature and rainfall in areas committed to agricultural use, changes in the frost content of Canadian and Siberian soils, and changes of ocean temperature in areas of high nutrient production, for example, that are of more immediate concern. We know from experience that the world's food production is highly dependent on the occurrence of favorable weather conditions in the breadbasket areas during the growing seasons. Because world grain reserves are but a few % of annual consumption, an unfavorable crop year, such as occurred in the Ukraine in 1972, has immediate international consequences. The current drought in parts of Asia and in Central Africa is producing severe hardship and has already caused the migration of millions of people. As the world's population grows and as the economic development of newer nations rises, the demand for food, water, and energy will steadily increase, while our ability to meet these needs will remain subject to the vagaries of climate. Most of the world's land suitable for agriculture or grazing has already been put to use, and many of the world's fisheries are being exploited at rates near those of natural replenishment. As we approach full utilization of the water, land, and air which supply our food and receive our wastes, we are becoming increasingly dependent on the stability of the present, seemingly normal climate. Our vulnerability to climatic change is seen to be all the more serious when we recognize that our present climate is in fact highly abnormal, and that we may already be producing climatic changes as a result of our own activities. This dependence of the nation's welfare, as well as that of the international community as a whole, should serve as a warning signal that we simply cannot afford to be unprepared for either a natural or a man-made climatic catastrophe. Reducing this climatic dependency will require coordinated management of the nation's resources on the one hand, and a thorough knowledge of the climate's behavior on the other. It is therefore essential that we acquire a far greater understanding of climate and climatic change than we now possess. This knowledge will permit a rational response to climatic variations, including the systematic assessment beforehand of man-made influences upon the climate, and will make possible an orderly economic and social adjustment to changes in climate. Limits of our present knowledge. Although we have considerable knowledge of the broad characteristics of climate, we have relatively little knowledge of the major processes of climatic change. To acquire this knowledge, it will be necessary to use all the research tools at our disposal. We must also study each component of the climatic system, which includes not only the atmosphere, but the world's oceans, the ice masses, and the exposed land surface itself. Only in this way can we expect to make significant advances in our understanding of the elusive and complex processes of climatic change. Need for data. Observations are essential to the development of an understanding of climatic change. Without them, our theories will remain theories, and the potential uses of our models will remain untapped. Our observational records must be extended in both space and time, so that we can adequately document the climatic events that have occurred in the past, and so that we can monitor the climatically important physical processes that are now going on around us. Much of the present climatic data are of limited availability and need to be put into forms that permit the systematic determination of appropriate climatic statistics and the assessment of the practical consequences of climatic variation. It is especially important that climatic data be organized and assembled to permit their use in conjunction with dynamical climate models. The oceans, in particular, exert a powerful influence on the Earth's climates, yet we have inadequate oceanographic observations on the space and time scales needed for climatic studies. The important heat, moisture, and momentum changes that occur at the sea surface and the corresponding transports that occur within the ocean are not at all well known. Recent observations from the Mid-Ocean Dynamics Experiment, MODE, reveal energetic oceanic mesoscale motions at subsurface levels, and our ignorance becomes even greater than we thought it was. The present international network of conventional meteorological observations has grown largely in response to the need for weather forecasts, while most oceanographic data have been collected from ships widely separated in space and time. For the proposed research program, these data must be supplemented by truly global observations of the large-scale geophysical boundary conditions and of the physical processes that are important in climatic change. It is here that satellite observations are expected to play a key role, as they offer an unparalleled opportunity to monitor a growing list of variables, such as cloudiness, temperature, and the extent of ice and snow. Other climatically important variables will require special monitoring programs on either a global or regional basis. It is essential, moreover, that the relevant data be collected on a long-term basis in order to acquire the necessary statistics of climate. Need for understanding. Our knowledge of the mechanisms of climatic change is at least as fragmentary as our data. Not only are the basic scientific questions largely unanswered, but in many cases we do not yet know enough to pose the key questions. What are the most important causes of climatic variation, and which are the most important or most sensitive of the many processes involved in the interaction of the air, sea, ice, and land components of the climatic system? Although there is evidence of a strong coupling between the atmosphere and the ocean, for example, we cannot yet say that we understand much about its consequences for climatic change. There are also indications in paleoclimatic data that the Earth's climates may be significantly influenced by the long-term astronomical variations of the sun's radiation received at the top of the atmosphere. But here again, we do not yet understand the processes that may be involved. There is no doubt that the Earth's climates have changed greatly in the past and will likely change in the future. But will we be able to recognize the first phases of a truly significant climatic change when it does occur? Like the familiar events of daily weather, from which the climate is derived, climatic changes occur on a variety of space scales. These range from the change of local climate resulting from the removal of a forest, for example, to regional or global anomalies resulting from shifts of the pattern of the large-scale circulation. But unlike the weather, variations of climate take place relatively slowly, and we may think in terms of yearly, decadal, and millennial climatic changes. But the system is complex, and the search for order in the climatic record has only begun. Even the barest outline of a theory of climate must address the key question of the predictability of climatic change. This question is closely tied to the limited predictability of the weather itself and to the predictability of the various external boundary conditions and internal transfer processes that characterize the climatic system. Although there is evidence of regularity on some timescales, the climatic record includes many seemingly irregular variations of large amplitude. How do we separate the genuine climatic signal from what may be unpredictable noise, and to what extent are the noise and signal coupled? These are important questions, and ones to which there are no ready answers. The determination of the climate's predictability will require the further development and application of both theory and dynamical models, along with a greatly expanded database. The answers, when they are found, will determine the limit to which we can hope to predict future climatic variations. Special attention must be paid to the fundamental role of the world's oceans in controlling the climate. The oceans not only are the primary source of the water in the atmosphere and on the land, but they constitute a vast reservoir of thermal energy. The timing and location of the exchange of this energy with the overlying air has a profound effect on the more rapidly varying atmospheric circulation. When the dynamics of this ocean-atmosphere interaction are better known, we may find that the ocean plays a more important role than the atmosphere in climatic changes. Need for assessment. We should add to these limits of our present knowledge the lack of comprehensive assessment of the impacts of climatic variation on human affairs. No one doubts that there are such impacts, for the specter of drought and the consequences of persistently severe winter weather are all too familiar in many parts of the world. Even so, we must admit that we cannot now adequately answer the question, what is a change of climate worth? A farmer may know what knowledge of the climatic conditions of the next growing season would be worth to him, but the answer in terms of national and international resource planning is more elusive. This lack of assessment is brought into sharper focus when we attempt to discern the economic and social consequences of possible alternate future climates. Future efforts and resources. Research approaches. Our future efforts must be guided by the realization that climatic changes in any one part of the world are manifestations of changes in the global climatic system. Since our fundamental goal is to increase our understanding of climatic variations to the point where we may predict, and possibly even control them, we must subject our ideas to quantitative test wherever possible. The recent development of satellite-based observing systems, the coming of a new generation of high-speed computers, and the emergence of models suitable for climatic simulation combine to make such an undertaking feasible at this time. The importance of climatic variations requires, moreover, that we use all methods of inquiry that are likely to yield useful information, and that we do so at the earliest possible time. The principal approaches to the problem that are available to us are shown in Figure 1.1, and we recognize the importance of maintaining a balance of effort among them. These same approaches form the elements of the climatic research program recommended in this report, and broadly cover what we believe to be the needed efforts for observation, analysis, modeling, and theory. The successful execution of the program will require contributions from the physical sciences of meteorology, oceanography, glaciology, hydrology, astronomy, geology, and paleontology, and from the biological and social sciences of ecology, geography, archaeology, history, economics, and sociology. A program of this sort calls for a long-term commitment from the scientific research community, from the sponsoring government agencies, and from the public. Figure 1.1 shows the interdependence of the major components of a climatic research program and a number of key questions. At the center is climatic data analysis, what has happened in the past. Around this are 6 interdependent components: monitoring, what is going on; empirical studies, how does the system work; future climates, how and when is the climate going to change; climatic impacts, what does it all mean to man; theoretical studies, how much do we really understand; and numerical models, what is shown by climatic simulations. The question of priorities. The various components of the recommended climatic research program, fully described in Chapter 6, are to a great extent interdependent. Data are needed to check the coupled general circulation models and to calibrate the simpler models. The models are needed to test hypotheses and to project future climates. Monitoring is needed to check the projections, and all are needed to assess the consequences. The question of priorities then becomes a matter of the priority of questions, and there appear to be no a priori easy guidelines to relative importance. Our priorities are reflected in those actions and activities that we recommend be implemented at once, and in those subsequent activities for which planning should begin as soon as possible. While anticipating that much further planning will be necessary to implement the complete program, we urge that the essential interdependence of the various efforts be recognized, and that all aspects of the problem be given support as parts of a coherent research program. Purposes and contents of this report. Broadly speaking, the purposes of this report are twofold. First, to advise the United States government through the National Research Council's United States Committee for GARP on the urgent need for a coherent national research program on the problem of climatic variation, and second, to advise on the steps necessary to address the same problem in the international scene. As noted previously, our response to the government is the recommendation of a broadly based National Climatic Research Program, NCRP, whose goal is the resolution of the problem of climatic variation.